Welcome to this video, another video. This video is on factorial notation and Stirling's formula. Chapter 2. Factorial notation and Stirling's formula. N factorial, which is written N with an exclamation mark, is called N factorial. It is a product of positive integers from 1 to n inclusive. That is, N factorial is what? N into n minus 1 into n minus 2 until you get to 1. And then by definition, 0 factorial is equals to 1. So that if we have 7 factorial, it is 7 into 7 minus 1 into 7 minus 2 into 7 minus 3 into 7 minus 4 into 7 minus 5 into 7 minus 6 into 7 minus 7, where the last one is also 1. So this will now be 7 times 6 times 5 times 4 times 3 times 2 times 1. That gives us 50, 40. The same thing for 6 factorial. Note that fractions and negative numbers can also be expressed in the same form. That means we can have factorials of fractions and negative numbers. So that half factorial is also equals to half into half minus 1 into half minus 2 into half minus 3. That is half times half minus 1 times half minus 2 times half minus 3 continuously. It is an infinite expansion. The same thing with minus 2 factorial. Minus 2 times minus 3 times minus 4 times minus 5. So 1 is subtracted from the next one, like that. But using this procedure, when we have n to be very big or large, with this procedure, it is quite impossible to have a good answer. So we will resort to an approximating formula that will give us something close to the actual value. And that approximating formula is called Stirling's formula or Stirling's approximation. That is, this approximation is for n factorial and is given as n factorial equals what? Root 2 pi times n raised by n plus half times e raised by minus n. Or you can write root of 2 pi n times n raised by n times e raised by minus n. Every other letter there or expression there is known except e. And we are told here that e is what? The value of e is 2.71828. For pi, we know that it's 22/7. Now this e is what? Is the base of natural logarithm. So we call this e natural logarithm. Or when we take the log of e or log of any number to base e, we are talking about natural logarithm or Napierian logarithm. I want to do something. Now we are going to solve problems using Stirling's formula. Problem 1 says use Stirling's formula to evaluate 30 factorial. Now solution. So let s equals to 30 factorial. We apply the formula now. This x now is equals to root of 2 pi times n raised to power n plus half times e raised to power minus n. For us to solve this problem, we are going to take the log of both sides. This log, we either call it log of s to base e or ln x. So we say we take the ln of both sides. Ln x equals to ln of 2 pi raised to power half. Remember, square root of 2 pi is the same thing as what? 2 pi raised to power half times 30 raised to power 30 plus half times e raised to power minus 30. Remember that in the law of logarithm, multiplication will change to addition. So if we expand this bracket and take the ln or logarithm of x to the base e, we now have that. We now say, okay, the same law of logarithm, this becomes half ln 2 pi. Multiplication now change to addition plus. Now 30 plus half is 30 plus 0.5, which is 30.5. So this now becomes 30.5 ln 30 plus ln e raised to power minus 30. Then this 2 pi, remember, pi is 22/7. So if you multiply 2 by 22 divided by 7, we are going to have 6.2857. And then plus 30.5 ln 30. Now, if you take the ln of an exponential function, remember, with ln x is the same thing as log of s to base e. So it will be log of what? E to base e. So this e to base e becomes 1. That's why you have minus 30 there. So ln of, or we can just conclude that ln of any exponential function is equals to the exponential function will disappear, because we are not going to have log of s, we are not going to have log of e to base e, which is 1. That is why we have minus 30 there. So the ln, we take the ln of this from your calculator. You can just type in this value under ln and you get the solution. When you divide by half, you have 0.9191. Then you do the same thing. Write 30, take the ln of that, multiply by 30.5, you have 103.7365. Then minus 30, you have this value. Like I said, ln x is the same as what? Log of x to base e. So we are now saying that log of x to base e is equal to 74.6556. Also, in the law of logarithm, if you have log of x to base e, it means e raised to power, that value, e raised to power 74.65 equals to x. So we say x is equals to e raised to power 74.6556. Then when you take the exponential function of this value, we are going to have 2.65 times 10 raised to power 32. Remember, it is Stirling formula or Stirling approximation. This value is an approximate value because it is manually impossible to get the direct value. So we use a Stirling approximation or formula to get this approximate value. To use Stirling's formula to evaluate 75 factorial. Solution, we follow the same procedure. Let y equals to 75 factorial. This time around we can represent the formula by any letter, either y, z, k, m. So we represent it by y this time. Now ln of y is equal to ln of 2 pi raised to power half, 75 raised to power 75 plus half, e raised to power minus 75. So we are now going to say half ln this value plus this. Remember, the ln of e minus 75, the e will disappear. We have minus 75. And so take the ln of this and multiply, divide by 2, we have 0.9191. Then we have this, the same thing, take the ln of this, multiply by 75.5, we have 325.9704 minus 75, and the value is 251.8895. That means that the log of y to base e is 251.889. That means y is equals to e raised to power 251.8895. Use your calculator, take the exponential of this. You are going to have 2.48 times 10 raised to power 109. That gives you the approximate value of 75 factorial. So I want you to try this exercise. Try this exercise also. Let's see what you are going to have. Use Stirling'S formula to evaluate the following: A, 45 factorial. B, 70 factorial. In our next video, we are going to look at this solution. Look at the solution of this exercise 2.